Welcome you all. In this session, we are going to discuss about the output equation of DC machine, output equation for AC machine. So, the output equation is the mathematical expression which gives the relation between various physical and electrical parameters of electrical machine. It relates the kVA output of machine with the main dimensions of machine. So this is what we call it as output equation. So the various notations which we use for deriving the output equation are V phase voltage, I phase current, Z phase number of conductors per phase, T phase number of turns per phase, Ns synchronous speed in RPM, small ns synchronous speed in RPS, small p number of poles, q specific electric loading, phi air gap flux per pole, b average flux density, kw winding factor, eta efficiency, cos phi power factor, capital D diameter of stator, and L gross core length. C naught is the output coefficient. In motor, the output equation can be obtained by the following. Consider a M-phase machine with usual notations. The output kilowatt is equal to input into efficiency. So the input power formula is M V phase I phase cos phi into 10 to the power minus 3 kilowatt input of motor. So the input power is represented by M V phase I phase cos phi into 10 to the power minus 3. So for a three-phase machine, let us consider it for a three-phase machine. Therefore, M is equal to 3. For M-phase machine, we have expressed the output Q value and input of motor. Now you are going to consider a three-phase machine. Therefore, M is equal to 3. I am going to replace this M by 3. Therefore, the input of motor is equal to 3 V phase I phase cos phi into 10 to the power minus 3 kW. Assuming V phase is equal to E phase. Therefore, if V phase and E phase are equal, then I can replace this V phase by E phase formula. E phase is equal to 4.44 F phi T phase kW. 4.44 F phi T phase into kW. So it is 2.22 F phi Z phase kW. T phase by 2 is T phase is nothing but Z phase by 2. So just dividing it by 2, you will be getting the value of 2.22 F phi Z phase into kW. So the frequency F is equal to P ns divided by 120. So capital ns by 60 can be represented as small ns, right? So I am replacing it. So I'll be getting F is equal to capital P into small ns divided by 2. So the output expression is 3 into E phase value 2.22 F. For F I am substituting this P ns by 2 into phi Z phase kW I phase eta cos phi into 10 to the power minus 3 kW. So now again 2 and 2.22 get cancelled, so you'll be getting 1.11 into P phi into 3 I phase Z phase into ns kW eta cos phi into 10 to the power minus 3 kW. The P phi is equal to total magnetic loading. So specific magnetic loading is B average and total magnetic loading is P phi, which is equal to B average pi d L, and also 3 I phase Z phase by pi d is equal to Q, that is total electrical loading. So I'm going to replace these two things in the output equation. So our output equation becomes 1.11 into B average pi dl into pi dq into ns kW eta cos phi into 10 to the power minus 3 kW. So now Q is equal to 1.11 pi square B average Q kW eta cos phi into 10 to the power minus 3 into d square L ns kW. So now just I am multiplying this 1.11 into pi square. So 1.11 into pi square is nothing but 11. So Q is equal to 11 B average Q kW eta cos phi into 10 to the power minus 3. So here the small q represents it is the specific electric loading, and the capital Q represents it is the kVA rating of machine. Therefore output equation Q is equal to C naught D square L ns. So this is the output equation for AC machine, whether it is an induction or synchronous machine. So now here C naught is equal to 11 B average Q kW eta into cos phi into 10 to the power minus 3. So here C naught is called as the output coefficient. C naught represents the output coefficient. Thank you.